Good morning, everybody. Astronomy 100 students. Today is actually Thursday, October 7th. As promised, we're going to go through basically 3 items today. The first one is the retrograde motion. We're going to go through all of the questions, basically go through all of the activities, what you need to do, okay? We're going to do the same thing for the lunar observation, basically project. That too, we're going to go through the questions and also go through the observations themselves. And then at the end, or at least while I'm talking about that, I'm going to also give you the style with which you're going to compose the project. Basically, the key point in here that you really need to take from the whole thing as far as the style and format, you have to put it in full sentences. Do not put something in short format. So when you're writing anything in science and communicating your ideas and you're given a question, do not give me the answer just like that without a full sentence. So you really have to put it in a full sentence, sometimes 1 or 2 items. So that's about the format. The other key thing in here, and that is key in general when we're doing science, if you have to report a number, numbers must have units. So you have to be mindful of that fact. You cannot just, if the question is asking you, for example, how many months, you cannot say 27 or 24. So you really have to report the months. Fortunately for you, at least this report, I put the units for you, but if you're gonna write about it, you are going to report the months. You cannot just say 24 or 23 or 17 or something with no units. So that's a key thing in here, 2 main things. We're going to talk a little more about this when we go in detail about this projects. So again, welcome to the few who came in late. But the point in here is we're going to go through these 2 projects in detail. Whatever we discuss today is also going to apply for the 3rd project that you're going to see. So let me share with you the retrograde motion PDF file. As the instructions suggest, you really don't have to use the PDF file, but it's a good idea if you can manage to do it, to use the PDF file. So I'm going to share with you the screen for the PDF file. The PDF file is a fillable file. It's a file that you can fill. Do not use your browser. I know the new browsers now tend to give you the ability to edit PDF files, but not all of them. Some of the older browsers do not. Okay, here is what I'm talking about. If I click in here and say open, or click on it outright to open it, it opens it in the browser. It opens it actually in Canvas. So if I try to fill the information in here, it may not even allow me to do that. I can see that this field is fillable. So if I'm going to write my name in here, it does not. I'm clicking, it's not doing it. But the thing with it is, and the instructor should tell you, this is the fillable PDF file. You must fill it with Adobe Reader, not Chrome, Firefox, or any other browser. So the first thing I really need to do to this file is download it. And when I download it to a place on my computer. Then grab it from the computer.
So first you have to download, right?
Download the file first on your computer, anywhere you like, then grab the file. It's a good idea to put it probably on your desktop, which is accessible easily. Then open it in your I don't know, am I sharing the screen? Probably I'm not. Let me share the screen for the what happened to it. Okay, again, let me go back step in here to show the assignment. Oh, let me do the student preview first, okay? So if I am a student, this is how it looks like to me. As I was saying, if I click on this file and open it, it's going to open immediately on Canvas. And this is useless for me because I cannot use it, honestly. I cannot fill it. The purpose of a fillable file is that you can fill information on it. Right now, if I click, it's showing me a field, this pink color, it's a field, but I cannot edit it. But if I open it with a browser, I think modern browsers, they let you edit these things, okay? But don't rely on them, okay? So I can fill my name in here, can fill my objective in here, whatever the objective is. This is the retrograde motion of the planets, so whatever you're going to write about the file. So it seems like Edge, that's the browser I'm using, Microsoft Edge, is letting me to fill it. But the problem rises when I try to save it. It may or may not save it. Okay, and which is key, because if I'm done with it, and I would want to come back tomorrow to work on it, and if it doesn't save, all the work I did today is gone. I have to do it again. And if I did everything and upload it to Canvas, and if it doesn't save, it's going to show me a blank file. It's not going to show me anything. So to circumvent that is two things. Either, and that's the best way, download the thing on your computer. Download the file on your computer. Do not do what I did right now, which was simply to click on it. That's not going to work. Actually, Canvas does not let you work on it. Does not let you fill it. So the first thing to do is click on this arrow to download the file. Once you download it on your computer, it's going to sit on your computer. Open it then with Adobe Reader, which is a free software anybody can have on their computer. So the Adobe Reader is a free software. Now, if that doesn't work, if it does not save, then open your whatever thing that you would want to use. You can actually fill it with a pencil or a pen. And at the end, take an image and upload the image. As long as you can print the file and fill it with a handwritten, as long as your handwriting is clear. Okay? Make sure your handwriting is clear. The A is distinct from the O, and all of the letters are clearly so that they can read them, and you can read them, and anybody else can read it. That is the key for your file in here. So, and this is true for all PDF files. So Adobe Reader is 100% free, and if you don't know where to find it, I'll be more than happy to share you the link where you can download the reader, and it works on any operating system, whether you have a Linux or Windows or a Mac. It doesn't matter what your computer is, you can use this one. Don't use your phone. This is a desktop thing or a computer or laptop thing. I don't know about the tablets either. Some tablets, they don't have this, okay? So if you have a tablet or a phone, you may need to print the file and take an image after you fill it manually and then upload the image, okay? So this is basically as far as the PDF file. So let me stop
For
sharing.
example, if you had a MacBook, can you download it?
Yeah, Adobe Reader is free for a Mac. Adobe Reader is free for Mac and Windows and Linux. It's anybody.
What about a laptop?
Yeah, same thing. It's free. Okay. The key thing in here is maybe the tablet. I'm not sure. Some tablets operating system will not allow you to download stuff like this one. So you may have a problem with a tablet, or you may have a problem with a phone. Okay. In which case, I would suggest that at least you print the thing and use manually, or do your own, open Word and basically say, question 1, here is my answer. Question 2, here is my answer, and so on and so forth. Okay, objective, and then you put your objective. You don't have to rewrite the whole thing. Just write basically the answers in the Word file, and then upload the Word file. So those are the alternatives as far as doing the project. So let me go back to it. Where did I put it in here? Okay, so let me share. So what I did now, I did exactly what you guys are supposed to do, which is download the file. Again, I'm going to put my name, and that's what you do, okay? And then here it's the objective. After you go through the project, which is basically plotting and things like that, then you understand. Obviously, this PDF does not have the instructions, so I don't know what these things are saying. It just has the report. So I really have to understand where to get all of this data from, where to get all of these questions from, because this is similar to a Word file. As a matter of fact, with Microsoft Word, you can open a PDF with Word and use it as Word and fill it. Forget about the Word. You can edit it. You can change this in Word. You can say instead of motion, notion. Okay, it says the end to end. But the thing with it is, that's the other option. So you have many ways of doing the report. Either print this form and fill it manually, or fill it electronically like I'm doing right now, or convert it to a Word file and open it with Word. So if you want help with that, if you want me to upload the Word file, I'd be more than happy to also convert to Word and put it for you guys so that you can do your own report. So the bottom line is you should not have any difficulty with it. And most likely I will put it on Word also, just to simplify it for you. Okay. Okay, so this is an old file, as you can clearly see, that I've used for other classes, but it's the same thing. It's the same report. Okay, let me stop sharing that file to go to the instructions now, because it's critical to understand where the data is from. So you need to have the PDF file with your instructions. So I'm going to open the instructions, and they're in this link. I don't know if I showed you where I got it from. So let me go back, step back, just to show you where the instructions are. So it's in here, the instructions. So I'm going to click on them, and it takes me to the instructions. Why I need them? I need this table. I need this data. Okay. To answer the first question, to do the graph, to do the plotting. So it says, I'm going to leave this data open in here, and I'm going to bring the PDF file to the other screen, and I'm going to read the data. So at this point, you should have the data in front of you, because I'm going to just refer to it while I'm plotting, okay? So I'm going to ask you to do the same thing so that we are on the same page, all of us. So I'm going to refer to this table that has this 3 rows, and they are the same 3 rows continuously. Instead of writing a big 3-column table, I wrote it in a 6-column, dividing the table evenly. So it's really the same date, extending all the way to November 10th, 2005, and then picking up from that date, which is November 20th, 2005, all the way to March 20th, 2006. So it's the same table, basically. And the data, you have the right ascension and declination for the positions of Mars, okay? So I'm going to refer to this table while I'm plotting this data. So I'm going to go back to the PDF file, and I'm going to move. Actually, I need to keep the, so I'm going to stop sharing. I'm going to move the PDF file in here. I'm in the browser in here. And let me share the PDF file one more time. Share the PDF file. Okay. Let's talk. The goal in here is to plot, to trace the position of Mars, basically. That's, I'm telling you this, but you're going to put it in your own words, because this is actual data from that table that we're going to actually plot the position of Mars versus the background stars. These dots in here that you see, they are the background stars. So if you're going to print this one, make sure that it prints at least to dark enough so that it does not lighten this point in here and you cannot see the stars. If it lightens them, circle them again with your pen or pencil or something. I'm going to drag the pen, and I'm going to go through July 10th, 2005, and see where the Mars was. July 10th, according to this one, was 1 hour and 13 minutes. So let me draw. What is the drawing tool in here? This editor. No, I don't mean to assign. I mean to comment. Okay. What is the commenting tools in here? Okay, you have to bear with me. Okay, if I'm going to do this in here. Edit. No, I'm looking for the commenting tool. This is a new okay, so we don't want this, we don't want save, we want the, I'm not too familiar with this one in here. Okay, let's see here if we can add a point in here. So basically, this is 1 hour and 10 minutes, 1 hour and 20 minutes, 1 hour and 30 minutes, 1 hour and 40 minutes, 1 hour and 50 minutes, 1 hour and 60 minutes, which is 2 hours. But according to the data, it's 1 hour and 13 minutes. 1 hour and 13 minutes, it's between 1 hour and 10 minutes and 1 hour and 20 minutes. It's somewhere in here, actually. So I'm going to draw a whole line in here, which, if I can find, this is a highlighter. This is a pen. Okay, so it's going to be one line like this. Okay, no, that's not good. Can I do it straight? Yeah, that's fine. Okay, so roughly, okay. Up to here is fine, okay? And then I really should not put it that high, okay? So let me change things in here. Let me delete it first because I don't want it to be too bright in there, but probably you might want to see it. Can you change the style? Okay, I can't. Doesn't matter. Okay, so that's one point, one line. The second line I need to be mindful of is the declination. The declination is the y-axis. The y-axis, it's giving me 4 degrees and 54 seconds, 54 minutes, I'm sorry, okay? Again, the angles can be also in minutes and seconds. 60 minutes is 1 degree. 60 seconds is one minute, and so on and so forth. So it's almost basically according to the table, and I'm saying in here that you guys have access to the table. So I'm referring to the data from the table. It's 4 degrees and 54 minutes. This is again 5 line. This is 4. It's 4:54. It's somewhere in here. So where these two lines meet is this point. So this point in here is the point that I want to draw. So this is the point. This point corresponds to 10, I mean, not 10, 7, 10, 2005, okay? So this is the point that I drew in here, okay? So that's point 1. That's where Mars was in the sky compared to this stars in the background sky night. I'm going to do this second point, which is 1 hour and 37 minutes. 1 hour and 37. Well, this is 1 hour and 20. This is 1 hour and 30. And this is 1 hour and 40. It's 1 hour and 37, which is slightly less than halfway. So it's this line somewhere. And according to the data, it's 7 minutes. This is 6 minutes. This is 7 minutes, slightly more than 7 minutes. So this is the second point in here that I'm going to draw, okay? So this is the second point that I'm going to draw. And this point now is July 20th of the same year. So this is 10 days later, okay? We're going to take a third point. Is everybody so far with me or not from the table translated to the graph? Can see the chat now. Okay. Okay, very good. So the third point, if you look at the table, can anybody tell me what the angle is, what the right ascension is, so that we work together on this? On August 1st. What is the number on August 1st? I need you guys to open the file and basically look at the same table with me so that we work together on this. I need the right ascension on August 1st from the table.
3 hours and 26 minutes.
August 1st, 2005. August 1st, 2005.
Oh, sorry, I thought you said October.
August 1st.
2 hours and 4 minutes.
Does everybody agree? It says 2 hours and 4 minutes.
On the right
Okay.
session, I
On the
believe
right
it's 2 hours and 22 minutes.
August 10th, that is. We're looking at August 1st.
How many hours is August 1st, 2005?
On the table. 2:04, or does everybody agree that it's 2:04?
Hmm.
Yes.
I don't know.
August 1st is 2 hours and 4 minutes.
Okay, very good. So it's 2 hours and 4 minutes. So if I look at that day, this is 2 hours, this is 10 minutes. 4 minutes is slightly less than halfway. So this is 2 hours. If I look at the right ascension, it's 9 degrees and 36 seconds, 36 minutes. So this is 6, this is 7, this is 8, this is 9. This is 10, of course. We're not in 10. We are 9 degrees and slightly less than halfway. Actually, 9.36, which is slightly less than halfway. Okay. Probably I made a mistake in here. It should be slightly less, but that's fine. So the dots, the red dots that you see in here are the positions of Mars in 30 days, basically. 10 days and 10 days and 10 days. Okay. What is it? 20 days, 20 days, 3 weeks. Okay. So far, so good. Now I need to know, and probably already said it, for August 10th. August 10th, I need the number. What is the right ascension for August 10th?
2 hours and 22 minutes.
2 hours and 22 minutes. So this is 2 hours and 10 minutes. This is 2 hours and 20 minutes. And 22 minutes, slightly more than 20 minutes. Slightly more than 20 minutes. And if I look at the declination, it's 11 degrees and 12 minutes. So this is 5 already. This is 10. This is 11. And 12 minutes is actually somewhere in here. Okay. 12 minutes is almost the fourth of the way, the fourth of an hour, the fourth of 60 minutes. So it's going to be here. So that is my position for August 10th. I'm going to do at least 2 more. And hopefully you guys are following by now. On September 1st, I'm sorry, before September 1st, we have August 20th. August 20th, it says 2 hours and 42 minutes. So this is 2 hours, 20 minutes, 2 hours, 30 minutes, 2 hours, 40 minutes. But it's slightly more than 40 minutes. And we have to go all the way to 12 degrees and 46 minutes. So again, 5, 10, 11, 12, and 46 minutes, which is almost 3/4 of the way. So again, this is on, I lost track of the dates, August 20th. Okay. So all of these dots that you see them are the position of Mars on those days. One more, on September 1st, it's 3 hours and 1 minute. 3 hours and 1 minute, we'll put it very close from 3 hours. Here is 3 hours. And then 14 degrees and 17 minutes. So it's 5, 10, 14 minutes, 14 degrees and 17 minutes. So it's going to be here. Okay. And so does everybody know how to continue this part? Or do you guys have a question?
No questions.
Okay. Everybody feels good about it? So basically all you're doing is taking the data and plotting it and keeping track of the date. Keeping track of the date, because this is in a date that happened first. This is the second day. Because if I'm going to plot it later on, I'm going to follow this line. This is how Mars appears to be moving in the sky in this direction so far. Okay. At some point, if you do the data, you're going to find it moving back like this. So that's how the pattern is going to look like. The ecliptic is where most of the time where all of the planets, including the sun, also move. This is the plane of all of the planets. Okay. Can we move on out of this question to go to the next one?
Yes.
Okay, very good. So basically what this whole purpose of this one is actually to take the data from the table and plot it using your favorite plotting tool. You can actually use it on using, if you are proficient enough, you can do Excel actually with it too, or you can do it by hand. Actually by hand will work fine if you, and don't worry about it. Is it exactly 37? Maybe it looks like it's 36. As long as you have it in the neighborhood and you have the correct position, so that's fine. Okay, so that's more or less how you're going to get the answer, and that's how more or less how the table would look like. I mean, the graph would look like. So the next part, question 1, actually, what is the ecliptic? I already defined what the ecliptic is. The ecliptic is where most of the planets basically move for more or less, and that's where the planets occupy. So that's the question number 1. So that's the question number 1. Okay, why does the orbital planet stay close to the ecliptic? Because that's where all of the planets move around the sun, because when the solar system was a big blob of materials, and then it starts to spin faster and faster, it's like you're having the dome flattened, and that's where everything is more or less located, and only fluctuations due to the collisions that happen slightly over time with outside objects that really altered their positions. Okay, even during their formations, yeah, they might form slightly, because the ecliptic is not exactly a sheet of paper that has no dimensions, it has finite dimensions. Okay, so that's the first question. What are the meaning terms of retrograde and prograde? In here, let me go back to the graph. This is a prograde motion. It's moving in the same direction as everybody else. And now this is the retrograde motion. And then it's prograde now. So the motion in the same direction, but it appears that sometimes moving backward, and then it's moving forward again like everybody else. So that is basically what this question is. On what, by the way, the book goes in depth in here about these topics. So I recommend that you guys go and consult also a book to make sure that nothing is missed in here. On what, on about what date did Mars begin to retrograde motion? On about what date did Mars return to prograde motion? So this is the date we're looking for here. This is the date that it started the retrograde motion, and this is the date where we're going to find when it's resumed its prograde motion. Okay, so retrograde is this arrow pointing backward, and prograde is this date. So we're looking for the day when this happens and the day when this happened. You can actually look at the table, or look at the table, yes, and you can find out more or less. But it's not really that obvious until you actually do the plotting. Then you're going to find this date. That's the first one where the Mars starts to go in retrograde motion. And then this date is when Mars is going to resume its normal prograde motion. So that's what the question is asking. Okay. End results. Now you're going to describe what you did based on the data. We plotted the motion. We found the time when Mars retrograde, and that date is so and so. That is in the year 2005 and 2006, according to the data that was given to us. And then on such and such date, which you're going to find, Mars resumed its motion in the prograde direction. So that's basically this question in here. Now, the second part, that is to model the retrograde, trying to see how can we understand it using either the, by the way, I received a message earlier that says the internet is unstable or something. So for some reason we get disconnected, please do not leave. I'll try to come back, okay? And be mindful of the fact that it will continue recording. So if you're going to discuss something, make sure it has no private information in there that might you might not want to be recorded. I will edit it up, of course, but hopefully you don't do that. Anyway, the point being in here, we're going to understand now. This is a fact. This is observation. This is real data. This is valuable information. There's a lot of information value because somebody sat meticulously every night on that table for 10 days in a row and collected that data for you. every night. As a matter of fact, they don't do it just these days. They do it for a long time, and then they pick the data just to represent, because the changes are minute between this point and this point, and this point and that point. That's why they assume in there that, yeah, but it's, you have data. Now this is actual information. Now we're trying to understand it. So there are two ways of looking at this. We're in this part now. We're modeling it according to the geocentric model or the heliocentric model. The geocentric model is the Earth is the center of the solar system. The heliocentric model is the sun is the center of the solar system. And in the geocentric model, we're saying in here is that Mars is going in a circle like everybody else. But if it's going in a circle by itself, it should be only doing prograde motion. It should be moving only in one way. But since it's moving backward, Ptolemy suggested that it's actually moving in another circle, and during at some point it's going to be moving backward in that circle, and that's how the retrograde happens. In the heliocentric model, where the sun is the center of the solar system, both of them are revolving around the sun, with the exception that one of them is moving slower than the other. So at some point the Earth overtakes the Mars, and it appears that Mars is moving backward. So that is basically in a nutshell what these two models are. Now, so you're going to go through the nomenclature in here and find the geocentric model, which is epicycle, and which is a different. That is going to be something that you can clearly see from the reading from the book. This one I leave it to you guys to read it from the book. If you have difficulty finding it, please let me know. I really want you guys to open the book at this point and make sure you understand that, okay? And then in the geocentric model, is a retrograde motion of the planet an illusion, or does the planet really move backward? Explain. So it's really not a real thing, okay? So does the planet really move backward, or is it an illusion? It really actually moved backward in this case. It's not an illusion, because it's moving forward, and then at some point it actually moves backward. So in the geocentric model, the motion is real. And again, you can read about it. So what I'm going to do in here, I'm going to draw a line and label this one 1. I'm going to draw a line and label this one a 2. I'm going to draw a line passing by 3 and label this one 3. I'm going to draw a line. Of course, I don't have a good drawing tool in here, so I'm just doing my best with what I have. I have a 4. Obviously, you're going to use a ruler. You're not going to rely on this drawing the way I have it. Or if you're going to use a pencil, it's fine. So on 5, it's actually slightly less than 4. That is when the retrograde is happening. On the 6, it's clearly less. That's where the 6 is. On the 7, it's obviously far more. On the 8, it's going to be slightly above the 7, meaning 4, that is when it started its retrograde motion. And it continued until the 7, then it went back into the prograde. In the 8th, and I know I should have probably used different colors because it looks all similar now. This is where the 8th is, the 9th is. On the 10th is clearly away from everybody. And on the 11th is here. So in a sense, the planet moved forward, prograde, and then it moved retrograde until position 7, and then it started moving again into position 11. So this is basically that part. And the motion is real because the planet is actually moving backward in the night sky. Okay. In the heliocentric model, is the retrograde motion of the illusion, or the planet really moves backward? In this case, it's actually an illusion. It's not. It's always moving in the same direction, both it and the Earth. So it appears to be moving backward, okay? Because of the speed, that's all. So again, from position 1 to position 1, I'm going to draw a line. Here is 1. From position 2 to position 2, I'm going to draw a line. Here is position 2. From position 3 to position 3, I'm going to draw a line. Here's a position 3. So again, now I'm on Earth looking at this planet, okay? On position 4 to position 4. So it looks like it's moving prograde. From position 5 to position 5, it starts to move backward again. So this is a retrograde. Position 6 to position 6, it's actually moving backward. It appears back as if it went back to the same position 3. According to my graphs, okay, these are not accurate drawings, so hopefully you're going to do a better job than what I'm doing in here. And then in position 7 to position 7, it appears to have moved again forward again. So this is the prograde. And then position 8 to position 8, it clearly has moved out away from this zone. And position 9 to position 9, it's in here. Okay. So again, the heliocentric model shows that the planet goes forward and then moves backward and then continues to move. But this is an illusion because in either case, the planet is always moving in the same direction. It never moves back at night. And here it looks like it's actually doing a backward motion, a real motion. Of course, that would be a problem because what causes a planet to reverse route and come back? That would be something you need to explain. You need a force to do that. There is no force that causes it. That's really why this model is not a good model, because you can argue against it easily. That this geocentric model would require a force of some sort to cause a planet to move backward. What is attracting it backward in there to pull it backward? So this is not correct to require something that causes it to change course. It was moving this way and all of a sudden it's moving backward, okay? But here, there is no need for any external thing because the only reason why it's moving in the same direction is because it has a velocity and it's being attracted to the Earth. It's like when you have a slingshot, for example, you put in it, what is that thing that you put the rope and you put a rock and you start spinning. The only reason the rock is not leaving is because it's tethered to your hand via the rope, okay? So it's not going. So there is that force of the tension of the rope that keeps it from place. Case in point, if somebody cuts the rope or if you let go, the rock will fly away, okay? So that is really the same thing in here. So what is keeping Mars and the same thing Earth is actually the proximity to the sun, and the sun is pulling on them with a rope that you can see. That's all. That is a rope. The gravity does not really require a rope. It requires it's a force at action at a distance. Okay, if you jump in the sky, there is nothing holding you between you and the Earth, but you come down because of the force of gravity. So even if you're jumping, there is a string that you cannot see. Doesn't exist really, not really a string, but it's a force of gravity that keeps you from flying away. Same thing in here. That is what keeps this planet actually tethered to the sun with the force of gravity. So in this case, there is no need for anything else because this motion is actually illusion. It appears to be moving backward in the sky, but it is not. It's moving in the same direction as the Earth is, except that the Earth is overtaking it and it appears to be so. How are we doing on time? Man, we spent a lot of time. Well, because the other project is actually light in terms of what we need to do on it. So we're fine. Question 7. Ancient philosophers would argue against the heliocentric model, stating that they did not feel the Earth moving as it revolved around the sun. What is wrong with this argument? Of course, it's the law of inertia. Okay, when you're sitting in your car, and if the car is going at constant speed, you wouldn't even tell that the car is moving. As a matter of fact, you can have your cup sitting next to you, and the cup will stay still, even if you fill it to the brim. As long as there is no bumps or there is no acceleration or deceleration, you would not even feel the water moving. The only reason why I see it moving, slightly shaking, is because the car itself is shaking, and there's some motion that you can see. I mean, you cannot really, it's not a big one, but it's there. So the point being in here is because you're sitting in the Earth and you don't feel it because you're moving with the same speed. Okay, but if some reason you slow down or you move faster, then you're going to see that, okay? To see the Earth moving away from you. If you disconnect the connection, which is a force of gravity. Again, the arguments in here is based on the models that you have drawn. Both of them show retrograde motion. One of them is real, namely the geocentric model, and that requires an explanation. And the heliocentric model, where the sun is the center of the solar system, is imaginary, if you wish. It's virtual, not real. And you don't need an external force to explain it because it's self-explanatory. It has to do with how fast one is moving versus the other. Okay. Okay. The last part of this one, the third part of the project, I told you guys it's a long project. Okay. The third part of the project is you're going to be given several objects, basically inner planets and outer planets. You're going to make predictions. What is the position of the exterior planet like Mars or Jupiter midway through its retrograde motion? So that's going to be either an opposition, okay? So Mars or Jupiter. Okay, let me go back into the share with you the other screen. Okay, so let me stop sharing and share with you this screen. Okay, the question is asking what is the position of the midway, the position when this outer planets, so this is the Earth, Jupiter and Mars, they're on the other side of the Earth. So when they are moving backward, midway is their opposition. Okay, they're in the opposition, okay? Whereas the inner planets, and there is another question that is coming down the road, and that's the question for Venus and Mercury, when they are actually going through midway through their also opposition, because then they are overtaking the Earth, okay? So in this case is actually the inferior conjunction. So those are the answers to the question. So the questions 8 and 9, okay? Can they undergo? Yes, they can, and they do. So the inferior planets, like Mercury and Jupiter, and that is question 9, they do it around this period of time, okay? Whereas in here, they're moving forward, and then all of a sudden, because they're overtaking the Earth, the projection starts to move backward in the sky, similarly, okay? And this one is like Mars and Jupiter. They do this in this position, the opposition. So the answer to question 8 is the opposition. Question 9 is the inferior conjunction, and you explain it using what am I saying? The positions basically, and which one is overtaking which. Okay. So let me stop sharing and let me share with you on the other screen. Okay, this table now that we need to fill, we need to find S. If you look at the instructions, S is equal to the period of the Earth, which is 12, times the period of the planet, for Mercury is 2.89, divided by the difference between 12 and 2.89. Regardless of which one is smaller and bigger, we're going to find the difference. So I'm going to get the calculator first of all going, and I'm going to show you how you find this number. So let me get mathematics. So at this point, I would suggest that you have a calculator. It does not have to be a fancy calculator. Any calculator would do, okay? Because we don't have to take square roots, or we don't have to take logarithm or anything complicated. We're going to multiply two numbers and divide by their difference. End of the story. So I'm going to share the calculator. So in this calculator, what I have is for Mars, for Venus, for Mercury, I'm sorry, the T for Mercury is 2.89, 12. 2.89 divided by open parentheses, the difference between them. That means it's always the bigger minus the smaller. The bigger is 12 and the smaller is 2.89. 2.89. Oops. 2.89. Okay. And this is the answer that I'm going to put in there. 3.81. I'm not going to put 3.806, 805. That's too much digits in there. Okay. Because of the sig figs, I'm only supposed to retain three up, and this becomes a 1. So the correct answer is 3.81. So I'm going to stop sharing and here the screen. I'm gonna go back and I'm gonna write in here. Oops. Undo. What is this in here? What is the text? No, normal stuff now. So in here, I'm gonna write 3.81. That's what the calculator gave me. For Venus, instead of 2.89 in the formula that I used earlier, I'm going to use 7.38. I'm gonna pick up Jupiter, for example. For Jupiter, the period of Jupiter is 142. The period of the Earth is 12. So I'm going to do 12 times 142 divided by the difference between 142 and 12, which should be 130, because 142 is bigger than 12. So again, I'm going to stop the calculator, the screen. I'm going to share the calculator. So this is Jupiter now. For Jupiter, again, 12 is for the Earth times the period of Jupiter is 142 divided by the difference between them. The bigger one is 142 minus 12. Okay? So the answer is 13.1, because this number is 0. It doesn't matter what comes after it. So it's 13.1. So I'm going to stop sharing the screen, come back in here. And write in here 13.1. Okay? And so on and so forth. So you're going to do the same thing for all of the others. You're going to do for Saturn. So you're going to do 12 times 356 divided by 356 minus 12. You're going to do in here, don't forget that that's the absolute value. The absolute value means that it's always positive. So you cannot have a negative number in here. 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 And you cannot have a negative number. So it's always positive. For series, we're going to do again 12 times 55.2 divided by 12, 55.2 minus 12. We're going to do in here 12 times 22.6 divided by 12.6, 22.6 minus 12. And here, we're going to do 12 times 7.38 divided by 12 minus 7.38. And we're going to find all of these numbers. Now, I have to make predictions. Here is when it gets funny, okay? February 26, 2020. I need to add to it 3 months and an 81% of a month. The month has 30 days. So I need to find how many actual days that is. So 3 months is going to be after February. It's going to be March, 1 month, April, 2 months. What is it? May, the 5th. So it's going to be May 26, 2020. But I have to add to it an 81% of a month. So I need to find how many days that is. So I'm going to stop sharing the screen and share with you calculator again, because I need the calculator in here. So I have 0.81 of 30 days times 30. And that is 24 days. 24 days in addition to May 26th. So May 26th. So I'm going to add May 27, May 28th, May 29, May 30, May 31st. That's 5 days. And then I'm left with 19 days. So it's going to be June 19th, 2020. So I'm going to come back in here, share. And right in here, it's going to be June, which is 6, actually, 19 of the year 2020. That is the next time when the retrograde motion happens. So it happens on February. It happened again in June. Okay, almost 4 months later. Let's look at Jupiter. It happens after 13 months. Remember, 1 year is 12 months. So it happens a year and a month later, and a 10th of a month. So let's look at it again. It happened the first time on September 13th. A year later, it's going to be September 13th, 2021. For that, I have to add another month to it, which is put it on October 13th, 2021, next Wednesday. okay? However, I have to add a 10th of a month to it. 10th of a month. 10th times 30, that's 3 days later. So again, I'm going to come back to the calculator to show you that that's exactly what it's supposed to be. I'm going to share the calculator. So I have a 10th of a month times 30. That is 3 days. So October 13th, 2021, add to it 3 days. That should put it on October 16th. 10/16 of the year 2021. Okay, October 16th is what day again? Is not this Saturday, but the Saturday after. Okay. So indeed, if we go outside on that night, and if we were monitoring the position of Jupiter, we should see it moving backwards. So this is the power of science. You can make predictions. Obviously, I didn't do the calculation for Venus or Mars or Ceres or Saturn. I'm going to leave it to you guys. If you have difficulty with it, please let me know. Okay. The biggest mistake I have seen when people do this one, they put the wrong sign in here. There is no negative sign, end of the story in here. It's always positive. And then after that, to make the calculation, remember, this is in month. So there is a fraction of a month in here. This is 81% of a month, which turned out to be, what is it, 24 days. 24 days and a third of a day. Who cares about the third of a day? I mean, if we're going to do this calculation, it doesn't mean October 16th. It could be October 15th because of the error that we did not account for, or October 17th. One of these 3 nights, you're going to see a retrograde motion. Because the data that you have reported in the graph was within a 10-day margin. So 1 day or 2 days does not really make much difference. So if we say 24, it could be 25, it could be 23 actually. But doesn't after September 13th, 2013. So that means 1 year and 1 month. 1 year would put it on October 13th, September 13th, 2021. And then add another month, which put it on October 13th, 2021, and add a 10th of a month. A 10th of a month is 3 days. So that put it exactly on October 16th, 2021. Then, based on the theory that was developed of the heliocentric model, based on the numbers that you have in here, you were able to make predictions. And at the end, the conclusions based on what you learned from this whole project. It's a long stuff to do. And if you have any questions, please let me know, or come back to this recording and watch it again. And you can watch portions of it. You don't have to watch the beginning if you want to. You can just skip ahead to see what the question that might help you with the answer to that. Sounds good?
Sounds good.
Okay, very good. So let me jump into the second one, okay? The second project right away, because I promised that we're going to cover both of them at least within the first hour, and then open it for discussions or anything else. So I'm going to go share the second project. Okay, here is the deal again with the same thing as before. Make sure you're going to download the Word file and open it and edit it. Okay. Again, if you're going to write your name, please double click on the arrow on top and put your name in there. And then double click inside and read through this. Read through this. Okay. You're going to have a little bit of information. If you are unsure about it, open the book and look at the different phases of the moon. Okay. Basically, let me go back into the graph in here, explain roughly what's going on. So the sun moves around the sun, apparently moving around the Earth. It doesn't really move around the Earth. The Earth moves around the sun. But for us sitting on the Earth, we see the sun going around, okay? The Earth completes a whole cycle around the sun in 12 months, in 1 year, okay? The moon goes once every month. So the moon moves a lot faster around the Earth than the sun in its apparent motion around the Earth. So for the moon to go once around the Earth, the sun has hardly budged on its axis. As a matter of fact, it's 1/12 of it, excuse me, of 360 degrees. 360 divided by 12. It moved 30 degrees in the night sky, which is really hardly much. Okay, it's moved from here to here. That's all. 30 degrees is not really a full cycle. So we're going to assume that it doesn't move much because it moved most part when the moon goes through a whole cycle. The sun, in its apparent motion, not real one, a virtual motion, appears to have hardly moved from the sky. Now, if the moon sits between the Earth and the sun, this is daytime. Of course, I'm looking at the sky in here. I'm looking at the sun, and there is somewhere a moon in here. But because of the way that the sun shines and hits the entire sky, you're not going to see anything. During that time, if I go in the sky, I will not find the moon. This is the new moon. And its motion around the Earth, is going to go through different phases depending on what time of the year it is, what time of the month it is. Okay, in here is going to start to show hardly an arc in here, the crescent. In here it's going to be a quarter, and in here it starts to grow. So this is a waxing crescent from here to here, actually, until I get into the first quarter. And in here, from here to here, it's a waxing gibbous, which means that it's actually the shape that is growing until I get into a full moon. In this case, the sun is shining on the moon completely and showing me a full circle of the moon. From here to here, it starts to decrease again. And it's going to be a gibbous, but it's going to be actually a waning gibbous until I get into a quarter again. Only this portions of it, if you wish, is shown. And then it's going to fade away, starts to fade again. The question is, basically, the first question is, where does this sit? Is this position A? If it is position A, it should be, or position B, it should be mainly lit, and it is not. It's hardly lit. It's actually a crescent. Okay. Is it in position C? If it's in position C, it's going to be halfway lit, and it's not. So it's neither A or B or C. The correct answer is either E or D. Here is the trick behind it. It's getting smaller and smaller. So it's actually the correct answer is D. So it's a waning crescent, actually. That's what you see, actually. If you see the moon, you will know exactly what time of year you are. If it's this part that is lit, you are actually in this halfway. If it is the other part that is lit, you are actually in this halfway. Okay. Again, please read in detail. I know I gave you the answer, but you have to read in detail. Make sure you put it in full sentence and you explain exactly the rationale that I presented in here. Okay, now it's telling you, look for the moon other than position that you determined for this position, actually. For this position is then A, B, and D, A, B, and C, and E, and draw the shape of the moon and how it looks like. For position A, it's really a waxing gibbous. And in this position, it's a waning gibbous, actually. It's the opposite. And here, one side that is not lit on this side, and the other side is one side that is not lit. And in here, it's going to be a quarter, halfway, basically. And in here, it's going to be similar to this shape, except the lit part is going to be this way. So it's a reverse this shape. So that's basically the answer to the questions. Make sense so far?
Yes, it does, sir.
Okay, very good. So now the last part in here is to actually go outside. That's why I answered these questions, because they're part of the lecture anyway, and you're supposed to find them in the book and get more detail about them. This is your job now. Starting from this coming Wednesday, less than a week from today, you're going to go outside. On the 13th, a day later is going to make much difference. A day earlier is going to make much difference. So try to stick to these days. And you're going to tell me the shape of the moon, again, based on what you have seen, okay? And you're going to name the phase. Again, the phases are going to be either it's a new moon, first quarter, full quarter, last quarter, or new moon, okay? And is it a waning crescent or waxing gibbous or waxing crescent or basically waning, or so that's basically the terminology that we're going to be using in here, describing what you see, okay? And you're going to draw it for all 3 nights, and you're going to report your conclusion in here based on your observations and what you have seen. There is no calculator in this one. It's only drawing, okay? And your watch to make sure that you're looking at things. This is a required project. I know it's a lot easier than the first one. That's why I require it actually, because you don't have to get too fancy with it, but it requires a field observation. That's the value of it, is actually going outside and doing your own observations. Okay, especially in nowadays Corona time, where we don't seem to have a lot of activities outside. So this is a good thing to go outside and do it. You don't have to do it with a group of people. You can do it on your own. Make sure every night you record your data, at least on a piece of paper and a pencil, and record the date and the time and all of that. Okay, I mentioned the format again. There is no numbers in this one in here. There is only drawings and descriptions. So we don't have to worry about that. When we're talking about descriptions, try to be use full sentences, not try, you have to use full sentences to describe your observations, your answers, and also try to keep it actually in the plural sense, like we or something like that, or say observations, shows. I mean, try to keep it as impersonal as possible. Make sure the vocabulary is clear, make sure the grammar is clear, make sure everything is well described, and use the terminology as you ought to do for both projects. Actually, for the first one, you have sometimes units, and as I said before, you don't really have to report the units because they are reported for you in a sense. Because for the S, for example, it tells you it's in months, so you don't have to mess around with the table. But for the actual conclusion and for the actual results and for the actual observations, so if you're referring to numbers, for example, for Mercury, it's going to occur 3.81 later. 3.81 what? 3.81 months, or 3 months and an 8/10 of a month. Okay, or to convert it in days, multiply the whole thing by 12. By 30 to get how many days there are. So units matter when you're communicating your ideas, okay? So this is basically in a nutshell what I promised we do. Do you have any questions for me about these 2 projects?
No, it's okay.
Okay, very good. Thank you, Ivan. Anybody else?
Can we work with partners in this?
Absolutely. Thank you, Christian, for mentioning that, because it's very, very vital that you guys try to work with partners if you can, okay? You're actually urged to do that. So thank you for a reminder, because I'm going to send another communications following this one and make sure that you guys have that clear, okay? So this is not an exam. This is not something this is actually an activity just like the homework, but it's going to help you reinforce some of the concepts that you learned in lecture and basically get you to do things and do them right and be able to communicate your ideas. So that's actually a recommended thing, okay? But if you do, I require that you actually name the person that you work with, that's all. If you guys don't have any questions, then I assume that things are clear. If not, again, please either come back to this recording or ask me questions about it. The key thing in here, the due date for the first product for the retrograde motion, it's due actually this coming 23rd of this month. So the time is really coming soon. The other one, the lunar observation, is due November 20th. Very good, thank you. However, it starts this Wednesday. It's not because it's due November 20th on November 19th I start working on it. That is too late. You missed everything. You missed everything. I mean, you probably will get partial credit for the first questions which I answered for you, but you're not going to get the bulk of the grade on it. You missed everything. So it has to start this coming Wednesday where you go outside and do things. Okay, no problem, Jordan. So again, I'm available. Hopefully you guys can get going on it. And if you don't have questions, please do not hesitate. The 13th and the 14th of the month, I'm going to be completely on campus for several hours, at least 7 hours a day on that campus, working on the from the rep of the vendor of the planetarium to go through all kinds of things in there to make sure everything is working and tested and everything else, because starting from the spring semester, some of these classes will be offered on campus, and we have to make sure that the planetarium is working. If everything works well, I don't promise, but probably we might have to do a session on campus if you guys choose to do so, to go through the planetarium and see the inside of it and do hopefully an activity in there or two. Okay. But I will be on campus on those 2 days, which is Wednesday and Thursday of next week. Okay. Okay, guys, if you don't have any questions, I'm going to stop the recording. I'm going to post this recording later on. I'm going to be on, it's going to be on Canvas. It's going to have its own special link. There is no discussion item for this one, with the exception that it's going to be discussion, but you can ask whatever question in there. And please do ask questions on the forum, because I may not be able to get to the answer quickly, but somebody else from your classmates may answer it and get going with it. So you don't really need my input if somebody else can do it and maybe explain it better than I do, okay? So we're gonna stop the recording and I will see you guys next week.